problem right here. The question is asking, given that the matrix A reduces to echelon form as follows. So they have done the Gauss-Jordan already, and the first question is asking, find the basis for the column space of A. What is the dimension of column space? So since we have a Gauss-Jordan pattern already, we don't have to do the Gauss-Jordan, so we can directly find the answer. So basically, uh, whenever they ask column space, whatever the column that carries the pivots, that's gonna be in the column space. So in this case, we have pivots in x1, pivots in x4, pivot in x4, and pivot in x7. So these are the three columns that's gonna be in the basis. So let's try this one. So therefore, answer for A is find the basis for column space. So we can say basis for column space A is equal A, B is equal. So this represent basis, and we are taking the columns with the pivot. So first column is 3 1 2 minus 1, 3 1 2 minus 1, and then second one is x4. X4 has a pivot. So pivot actually, so here we go, 2 1 1 minus 1, 2 1 1 minus 1. Then x7 has a pivot. So let's take the x7. That's 3 1 2 2, 3 1 2 2. So these are the three columns that's going to be in the basis. Then the question also asking what is the dimension of the column space. Since we have three vectors, three linearly independent vectors in the column space, the dimension is going to be number of vectors. So therefore dimension is equal to 3. And this next question is asking, find the basis for the null space of A. What is the dimension of the null space? So first, to find the null space, what we have to do is we have to bring this pattern, bring this Gauss-Jordan and equalize to 0. Like for the null space, the equation is Ax is equal to 0. Then what I have to do is I have to bring this Gauss-Jordan pattern. So let's see. So we have 1, 2, minus 2, 0, 1, 2, 0. And the second is 0, 0, 0, 1, minus 1, minus 3, 0. And the third one is 0 all the way, and at the end we have 1. 0, 0, 0, and at the end we have 1. And the last one is 0, all of them are 0. So all of them are 0. And now we have to equalize this one to 0. So this is the null space. Now what I have to do is I have to find the free variables and solve all the systems in terms of free variable. So in this case, we know that x1 is not a free variable. So x1, x4, x7, those three has pivots. So this doesn't include as free variable, except all of the other columns are going to be free variable. So in this case, x2 is a free variable, x3 is a free variable, x4 has a pivot, so it's not a free variable, x5 is a free variable, and x6 also a free variable. x7 has a pivot, so it's not a free variable. So what I have to do is I have to write these three things, x1, x4, and x7 in terms of free variable. Then I can finally find the vectors of column null space. So in this case, first solve for the x1. So if I take x1, so first I have to create the equation. So equation is going to be x1 plus 2x2 and minus 2x3. Then 0 x4, we don't have to write that, and x5 is 1, so plus x5. Then we have 2x6, so plus 2x6. That's all we have. So equal to 0. Now if you see, except x1, all of them are free variable. x2 is a free variable, x3 is a free variable, x5 is a free variable, x6 is a free variable. So if I bring the others to the other side, I can solve x1 in terms of free variable. So therefore, x1 is going to be equal to minus 2x2 plus 2x3 minus x5 minus 2x6. So this is my x1. Now x2 we don't have to solve, it's a free variable. X3 we don't have to solve, it's a free variable. X3 we have to find it. So to find the x3 I have to solve in terms of free variables. To solve that I can take the second equation, second row. So if I take this one, this is going to be, this is x4. So x4 minus x5 minus 3x6 equal to 0. Therefore x4 is going to be equal to x5 and x6 are free variables, so I can take both of them other side. So x5 plus 3x6 is my x4. Then x7, it comes out to be 0, so we don't have to do anything about that. Now what I have to do, I have to arrange everything from x1 to x7. So let's arrange that. X1 is going to be this one in terms of free variable. So 2 minus 2x2 plus 2x3 minus x5 minus 2x6, and x2 is going to be itself because it's a free variable. So x2 is going to be itself. X3 also going to be itself because it's a free variable. X4 we had to solve in terms of free variable, so we found out already it's x5 plus 3x6. So it's going to be x5 plus 3x6, and then we have to find x5. x5 is going to be itself because it's a free variable, and x6 is going to be itself because it's a free variable. x7 is 0, we found out already, so we can put it as 0. Now what I have to do is, since they are asking for basis, we have to bring the basic format. Like I have to take everything common. Like for example, if I take x2 common, I have to take everything, not only x2. I'm going to do for everything, but let's do one by one. So if I take x2 common, what's going to happen? In the first one we have minus 2 x2. In the second one we have 1 x2. In the third one we don't have x2, therefore it's 0. Fourth one we don't have x2, 0. Then fifth one we don't have x2, 0. Sixth one we don't have x2, 0. Seventh one also 0. So this is x2. Thus now I have to take x3. So if I take x3, we have 2 right here. Then we don't have anything. We have 1. Here 0, 0, 0, 0. And let's take the x5 now. So if I take x5 minus 1, 0, 0, and we have 1 here, and also we another 1, and 0, 0. And now if I take x6 minus 2, 0, 0, we have 3 right here, 3, and then 0, then here we have 1 right here, and this is going to be 0. So when we write the null space, so we have to, the null space is the question, so I continue maybe right here. Okay, null space of A. And when we write the basis, we have to eliminate all these x2, x3, all these things, because we only want the basic format of this one, so we only want the numbers. So when you take the basis, so it's going to be null spaces. Therefore null space A basis is equal to minus 2 1 0 0 0 0 0, comma 2 0 1 0 0 0 0, comma minus 1 0 0 1 1 0 0, comma minus 2 0 0 3 0 1 0. So this is the final answer for null space. Also they are asking for the dimension of the null space. The dimensions of the null space going to be basically the vectors in the null space. So if you see, we have 4 vectors right here, so 4 vectors, and also you can consider the free variables. If we have 4 free variables, that's going to be the dimension. Therefore, the dimension of null space is equal to 4. And then the third question, C question is asking, find the basis for the row space of A. What is the dimension of the row space of A? So this is C question. So to find the row space, basically it's going to be the rows with the pivots. So if you see, we have the pivots in the first row, second row, and the third row. So we have to write all these 3 rows as a basis. Therefore, basis, let's say row space base of A, basis is equal to, we can write this one as 3, 6, minus 6, 2, 1, 0, 3. Then we have 1, 2, minus 2, 1, 2, minus 2, 1, 0, minus 1, 1. You can write vertically or horizontally, it doesn't matter. So as long as you have everything right, you are ready to go. Now let's take this third row. It's going to be 2, 4, minus 4, 1, 1, 1, 2. And these are the 3 rows that has pivots. Therefore, this is the basis of row space. And what is the dimension of the row space? If you see, we have 3 vectors in the row space. Therefore, dimension of the row space is equal to 3. And the last question is asking, state the rank of A. Rank of A is basically the number of pivots we have. If you see, we have three pivots here. Therefore, rank is equal to 3. So that's the D question. And the E question is asking, is the vector 3, minus 1, 1, 2, minus 1, 1, 0 in the null space of A? So what we have to do is, we have to set this one into Ax is equal to 0 pattern. So in this case, what I have to do, I continue here, maybe different color to avoid confusion. Okay, let's do this here. So what I have to do is, I said bring this Gauss Jordan pattern right here. 1, 2, minus 2, 0, 1, 2, 0, 0, 0, 0, 1, minus 1, minus 3, 0. Then the last one is 0, 0, 0, 0, 0, 0, 1. Then last one is 0, 0, 0, 0, 0, 0, 0. Now this is my A. And X, this is X. So X vector mean that's a X. So we have to consider this one as X. So let's arrange this in a column space first. So column as a column. So 3, minus 1, 1, 2, minus 1, 1, 0. So if this is the vector in the null space of A. So if this vector in the null space of A, what has to happen is, when we multiply these two together, this should give us 0, 0, or all the values should be 0, because that's basically null space. Null space is Ax is equal to 0, right? So if this is in the null space, when we multiply and add them together, we have to get 0. So let's see whether it's true. So if I multiply, so since this is what is 4 by 7 matrix, 4 by 7 matrix, and this is 1 by 7 matrix, so it's 7 by 1 matrix. My final answer is going to be 4 by 1. So let's multiply. So 1 times 3 is going to be 3. So let's add it. So 1 times 3 is 3. 2 times minus 1 is minus 2. Minus 2 times 1 is going to be minus 2. 0 times 2 is 0. We don't have to write this. And 1 times minus 1 is going to be minus 1. 2 times 1 is going to be 2. And then last 0 times 0 is 0. So let's add this together. 3 minus 2 is going to be 1. 1 minus 2 is going to be minus 1. Minus 1 minus 1 is going to be minus 2. Minus 2 plus 2 is going to be 0. So this is 0. So my first row is 0. Then let's do the second row. 0, 0, 0. So these 3 are gone. Then 1 times 2. 2 minus 1 times minus 1 is going to be plus 1. Minus 3 times 1 is going to be minus 3, then 0 times 0 is 0. So if I add them together, 2 plus 1 is 3, 3 minus 3 is 0. So our second row is 0. And the third row, let's go to the third row. 0 times 0, so all the way 0. So 1 times 0 is 0. So this is 0. The last one we know it's 0 because the row is entirely 0. Therefore the last one is 0. Therefore we have all the values with 0. Therefore we can say this vector is in the null space of A. So we can say therefore this is a vector in the null space of A. So this is the final answer, and that's how we do this question. I hope you guys like this video. See you next time.